So just before I get into it, I just want to provide some brief background. This project is part of the Spencer Gulf Ecosystem Development Initiative, or more affectionately known as SCEDI. And it's a large initiative, and at the moment we've got several interrelated projects under SCEDI's umbrella here. The one I'll be focusing on is here, the habitat risk assessment, and that the data generated from this directly feeds into another project, and there's a poster on this project here today at the conference. So I just want to briefly, what is a risk assessment? Well, risk is formally defined as the effect of uncertainty on objectives. As an ecologist, I have no idea what that means. So another way you might think about it is the probability of your management objective, and ours might be to keep the beautiful marine habitats in Spencer Gulf beautiful, so those objectives are not achieved. So you have threats from A to Z, and you want to rank them from the highest probability that your management objective isn't achieved, so your threats aren't going to stay pristine, to the least. So we had multiple risk units, so multiple habitats here. We didn't just select one. We've got 8 broad-scale habitats. Some were removed because there was a limited amount of expertise, but that was an interesting data gap in itself. We had 37 potential threats to Spencer Gulf. We consulted more broadly with making up this list, but it was quite a diverse range of threats. So that equates to nearly 300 threat habitat combinations. That's quite a Herculean task. So where do you begin to start? And it sort of is a conundrum, because ultimately data is very deficient, particularly in marine systems where it's under-resourced, and Emma's keynote highlighted that. So we don't have the hard facts and figures in which we rank everything, 300 habitat threat combinations from A to Z. Time is limited. We had 6 months to do this project, and as you know, resources are always tight. So what can you do? You can one solution is to do a screening level assessment, and that's the key word here. So that's your first pass base level assessment before your more detailed assessments are done. So it's critically to facilitate future resource prioritisation, and then also identify your knowledge gaps and uncertainty. But before we wanted to do this, we wanted to design our own framework that fitted our needs. We wanted it realistic and feasible with our limited resources. It's comprehensive, so we had diverse habitats from extra-tidal salt marshes to pelagic, and a really diverse range of threats as well. And we also want to be able to pick this risk assessment up and be able to do it somewhere else in the world, or you may also want to repeat it in time in Spencer Gulf, say in 5 years' time. We also wanted to ensure it was compliant with the international standards, and one of the advantages of these is you have to read the international management guidelines, and it's a really gripping piece of non-fiction. So I'd recommend that you read it. So we decided to elicit our expert opinion through individually administered surveys. Why? Because you can get coverage over a large group. They're also very transparent, more than, say, a group discussion or consensus, which may be, and it's also dominated by, you know, a couple of alpha personalities in the room. It's highly structured, and it's also very resource efficient. So I think all in all, our surveys took up 40 volunteer hours spread across 40 people. So the general approach we used was exposure consequence. Exposure was a function of likelihood. You might be more familiar with the term likelihood, but exposure can be more relevant to ecological threats, which tend to be continuous and ubiquitous, rather than your one-off rare risk events, which might be more familiar to risk, hazard management. So this is just a very simple summary of the approach. So the survey respondents scored a consequence. There was different criteria when a threat was present in a certain habitat. And then we did a spatial exposure score, which was generated by the project team using expert opinion and also some quantitative spatial data layers. So this is just an example of our habitat layers in Spencer Gulf that Alice Jones generated, And here's one of our more quantitative spatial layers. This is shipping in and out of the Gulf, so that you can overlap the two and generate the score. So we multiply those two together to get an overall risk ranking. We also wanted to do something a bit different with uncertainty because it's expert opinion data. You can make so for a given risk ranking generated by expert opinion, you want to show how uncertain that is. So we did a most likely scenario for consequence in the survey. That was our default go-to consequence. We also asked survey respondents to look at best and worst case. So we have an idea around the risk range. And the difference between the two was our uncertainty score. So the survey statistics, our experts were habitat experts more rather than threat experts. They were generally focused on, they had an understanding of Spencer Gulf, so it wasn't an Australian-wide survey. So this was in late last year for a couple of months. We had 60 experts, did 80 surveys. It's because some experts they were very tenacious and did multiple surveys, battled that survey fatigue and did, some up to 4. So we got reasonable sample sizes for some. This is the sample size here. Seagrass is by far the most loved habitat. We had to stop people we easily got that number, and seagrass, we had to encourage people to do other habitats they had expertise in, just to balance out the scores there. So that's an interesting knowledge gap in itself, is how many people we got to do the different surveys. Generally, half university, half state government, and this is the years of experience with each given habitat. So we had a spread of experience levels, but most people had a few years under their belt. So this is just the data for one habitat, so I wouldn't bore you with showing lots and lots of graphs. This is for seagrass, so this is directly from the survey. And this middle dash here is the most likely scenario, and this is how they're ranked from highest consequence to least. And this is the best case to worst case here. And this is just to show this data is directly being used to generate cumulative impact maps in Spencer Gulf. And I think Alice Jones will be standing by her poster tonight during the social mixer if you want to know more about this project. So this is just some of the uncertainty data we can generate. So we've got an uncertainty score, again for seagrass, the threats, and we also categorised the spatial data, the quality of that, because obviously it varied quite significantly. We had some big gaps there. So this is the result of the risk analysis. So I did it as a word cloud. So the size of the words are weighted according to the size of the risk score. So the higher the risk score, the higher the risk, the greater the word. And so risk again is consequence multiplied by spatial exposure. So this is for seagrass. So we've got some big ones coming out from global warming, acidification, nutrient discharge, boating. That's all boating activities except your large ships, and hot weather events. Just for some contrast, here's one for pelagic systems. Again, we're getting this predominance of climate change. And just for something different, here's mangroves. We've got acid sulphate soil and things like heavy metals, which you might not think of as big threats. I'd like to show them all, but time's a bit of the essence. This is what I'd like to call the mother cloud. This is like all the threats together. I totaled all the scores just to show you which ones come through across for all habitats as you go. There's still that predominance of climate change stresses. And interesting, some of the ones that consistently ranked low were invasive species and a lot of the fishing threats as well. So the conclusions is a screening level assessment is not to say this is the highest risk and we need to be scared of it. It's sort of to provide a starting point of high risk and highly certain threats for which we could build more detailed quantitative assessments. So this is just a really sort of crude back of the envelope example. We've got seagrass, we've got the top 10 threats ranked by uncertainty, consequence and risk. You might have a look at finfish aquaculture because the consequence of that is highly uncertain, but the average consequence is high and risk is high. But if you looked at it more, that might go up and down in the risk ladder a little. 2 minutes? And boating, it's high risk, you might want to look at that. The spatial data there is very hard to sort of look at, but it's high risk. And then you might look at dredging. We also included some near future threats. So dredging was one of ours, such as world brine discharge that's not yet occurring in Spencer Gulf. So we just generated a consequence score. As you said, it's very high. So you might want to look at the future extent of dredging with increased shipping in Spencer Gulf with the larger ships. And then also you've got the pervasive climate change threats. So this is where you might begin to think of your management objective is to keep seagrass beautiful in Spencer Gulf with a finite amount of resources. So there's some of the questions you might ask by looking at our risk assessment. That's all. Thank you.
Thanks very much, Zoe. Time for a couple of questions if they've got quick answers. Okay, and I have to be one of the people who apologise for not having filled out the survey despite having been asked.
I remember you.
Hi, Zoe. Where to from here?
So Bronwyn, is Bronwyn here? We would like to, this is the environmental side of things, so it would be good to look at this in terms of the socio-economic side of things. Secondly, we'll be looking at using this data for all the stress maps on a spatial level, and then that can be looking at what might be looking at in the future as well. This was to get the baseline, and then another step might be doing the risk evaluation side. So this is predominantly focused on the risk analysis, so your evaluation might be at what point where your risks will be categorised as high or low and where you look at them next.
That was my question, so I'm going to change my question. So did you ask the experts to review the threats in relation to the context of current management or the history of impact? Because they're just two things that we've found really difficult when we're getting expert opinion, is to say, how are they making these judgments? Is it on the basis of what's currently being done, so hence we don't have to worry about it, in which case there's a management strategy underpinning their threat assessment? And also, is there a baseline that they're kind of judging it against? I wonder what kind of information you gave the experts.
We didn't specify like what was in terms of current management practices. I suppose it was their current state. We looked at the impact on trophic structure and also the physical habitat structure. And we didn't make those specifications, but that is actually a really good point. One of those ones would come up is oil spills, because that's a really tricky one, because at what level, the level of threat would depend hugely on the level of management and mitigation that's currently put into it. But no, that wasn't defined, so it would be the latter.
Got time for one more question?